So I'll quickly start, and probably for some of you, it may be very basic stuff. We are repeating the basic concept to bring everyone on the same stage. Let's go ahead and talk about what is cloud computing. Now, what I'm going to share on screen is a picture. Hopefully everyone can see the picture. Can anyone tell me in the chat what this picture is all about? I can guarantee you this is not a coffee machine. This is not a espresso machine which will give you a hot coffee in the morning. Any guess here, any thoughts what this machine would be representing? Sagar is saying it is server, could be. Let's see what others people think of. A power plant, turbine. Yes, Sachin, it makes sense. If power plant, yes, a turbine. Data center. Nivedita, I like that. And then turbine, Pavan, and hydro power plant. Yes, Jai, it makes sense. And then yes, this is supercomputer. Yeah, we want to make this supercomputer. And this is a huge thing. If you see here, there's a person standing, and you could realize the scale of it. And if you guess that it is a power plant. Yes, it is a power plant. Now, why I'm discussing power plant into cloud training, let me explain that. So, 100 years ago, not very, very far from the reality, everyone who wanted electricity, they had to build this kind of plant. They have to build and maintain their own power station. Imagine it. Now you may be thinking, hey, electricity is available with just a push of a button. Why we need a plant like this? So this was not a way of delivering electricity 100 years ago. So anyone, any town, any manufacturing unit, they wanted to have electricity, they have to maintain then build this plant. And obviously it was a challenging stuff. Challenging stuff was that it was the initial cost involved. There is a huge money to be paid to get this plant commissioned. And then second, there would be a lot of ongoing maintenance because it is a plant. There would be machinery, there would be wear and tear, manpower to be paid, and that would be a long commitment you are making. And that was a deterrence for a lot of people to go and get electricity. But if I look at today, how we evolved, we just press a button now. And that button could be to light a small bulb, or it could be light the whole industry, or maybe the whole city. It doesn't matter. Everything is available at push of a button. And the best part is we pay as you go. We do not pay any upfront money. If 1 month, because of, let's say in Europe, the uh, cold is there and we need more heating in the house, my electricity bill would be higher. But in the summer, my electricity bill would be lesser. That depends, because purely it is a pay as you use model. So how this compare to cloud? Because what we are showing here, this is a utility based pricing. You are consuming a utility, a electricity or a water supply that is being consumed as a electricity, as a utility. And the same thing applies into cloud also. Let's do a compare. Somewhere somebody is generating electricity. The method they use will depend. Maybe they are using hydropower, maybe they are using nuclear power, solar power, or whatever method they feel comfortable with, or whatever is economical, they would generate electricity. Once the generation is happened, that generation distribution has to start. Once your electricity is available, it may be in a remote part of the world, and then it has to be distributed. So they have to set up these kind of grid sections. And once this grid is ready, then it reaches to consumer and consumption can start now. That's how your electricity model works. Cloud is no different. In cloud, somebody has created resources. It could be a load balancer. It could be a S3 bucket. It could be a storage system. It could be a it could be elastic compute. Could be anything. So different type of resources are available in cloud, and the cloud provider has created an infrastructure which would allow you to use all these things. And afterward, through internet, which becomes a distribution medium, we are able to distribute all these content or the resources to the user of our choice. So that is how they are comparing that there is a generation happening, there is a distribution happening, and then users start using these services. So that is a very basic stuff, how our cloud platform has evolved and how it is helping us to do a pay as you go pricing. All right. If you have any questions, keep on sending them into chat. Our team is looking into the questions and we would be happy to respond as many as we can. Right. Now, so cloud is there, and let's now focus on AWS so that you would have a little bit more idea on what AWS is and how it started. So AWS is providing you a cloud platform. I would use a word here platform because this is a platform on which you could start building. So there are some basic tools available, and then based on your requirement, you can keep on adding more components. So it's a very extensible platform and very robust platform. You could use it. This was made publicly available in 2006. It has global presence, working from all over the world, different location, 200 plus services offered. We will talk about some of them. And the good thing is utility pricing. If I use a service for a few hours or few minutes, I only pay for that much. I do not have to keep on paying for high time for higher time. So this is a utility based pricing, and they give you a free tier to get started, which we Prasad would talk a little bit more, so that you can start building and practicing things on your environment. So that should not be a problem at all. So that is how things would be working. So that is what AWS is. Now what AWS platform is made up of, it is made up of different layers. Now, this may be a little different definition from the official ones, but for me to understand things, I prefer to see things into layer. So what we are seeing here, we have a global infrastructure at the back. This is the backbone of everything in AWS. I'll talk about these things: region, availability zone, edge location, and on top of that, there are foundation services. So three foundation services: compute, networking, and storage. These are very common thing which you would need for anything. So let's say you want to host an application. Your application would be processing some code or accepting user logging or a social media, whatever. You would always need compute, which will allow you to do processing. You need to process the data. Processing could be processing the image people upload, or processing the login request which is coming up, or processing the packet they are sending to us. So that is your compute resource. Then comes networking. Obviously your app need to be accessible by multiple people, or maybe behind the scene it will be talking to some other systems for logging or maintenance or for update. So we need networking to be sorted out, and their app would obviously be storing some data so that a user can access the data again. So these three are very fundamental things for whatever you do, whatever application you could think of. There would be a compute part, there would be a networking component, and there would be a storage component. So that is exactly what we will be discussing into the foundation services. And once we have a better understanding on these foundation services, we would then start talking about different platforms like databases, analytics services, management services, and deployment services on top of it. So my focus today would be to talk about this global infrastructure and let you understand the basics of region, availability zone, and edge location. All right. I hope everyone is following along. If there are any questions, any doubts, any confusions, put them into chat. I'm also monitoring the chat, and if some questions require me to explain it, I would be happy to explain it. Okay. Now, what is this global infrastructure is made up of? Let's go ahead and see this thing. So this one is available in this slide. Okay. Now, what we will be doing, we will be pushing this slide on to the GitHub link. So you would have access to this slide, no problem at all on that. Every content would be made available to you in a PDF format so that you could reference that again if the need be. So what AWS has done, depending on the customer need, depending on different criteria, AWS has set up something called a global infrastructure. And if you want to look at it, here is a link I am trying to open into the console, which probably everyone can see that. This one is my global infrastructure. So AWS Global Infrastructure is made up of 31 regions, 91 availability zone, 410 point of presence. So this is the places all over the world where AWS has physical presence, and from there they deliver their services. So we'll see how this delivery of service actually happens. But the baseline is they have placed data centers all over the world and connected them together so that delivery of the content, delivery of information, delivery of application can happen in a efficient fashion. So that is a global infrastructure. If you want like a little more 3D view of this data, then here is a website where you can see these things into a little bit more interactive fashion. This is your website where globe is present, and then you can see things like in this fashion. So interesting place where you could go and check some of the basic stuff of global infrastructure here. So this is a global infrastructure. If you see all these locations where resources are available, and you can start building your application easily. So if I talk about Europe here, then in Europe, these are all the places like Stockholm, Frankfurt, Paris, London, Ireland, which are treated as a region. These links will be made available to you in the slide, so don't worry, you would have access to all these resources as we speak. So it is currently made up of 99 availability zone and 31 geographical region. So let's see what this geographical region is and what is happening inside them, how they are being hosted. This is what these regions are, and I would share these links to you. So let's see what is happening behind the scene on that. Behind the scene, everything is a region. Right. So behind the scene, everything is in data center, and data center would be made up of server racks. So let's say one server rack. Obviously, it may not be sufficient enough for holding a lot of data. So what you would be doing, we would be putting these server racks into a entity called data center. So data center would be your physical locations where a lot of servers are hosted, and through these servers, we deliver the content or resources or application. And in that data center, it's not only the server which are doing processing, but additional resources associated with that, like you would need internet connectivity, you would need routing services, you would need load balancing services, storage services. So all of these things are put together into a data center, and a data center may have up to 50 to 80,000 servers in it. Why we are not creating a huge data center? Because let's say you created a huge data center, and in that data center you had, let's say, 200k servers. And if there was a problem with this, 200k servers would be affected, users data would be affected. So better is to keep blast radius small, and let's go ahead and instead of putting everything into one single place, let's go ahead and put 75k server here, maybe 75k server here, and maybe 50k server here. Just give an example. So we are trying to reduce the impact something may have because of a single point of failure. So this is what a data center is. Now, data center are hidden in the plain sight. What I mean by that, that we do not officially publish any location that, hey, this is building number 12, or this is the address where you will find a data center. So we keep this information internal. Even employees, me, Jamila, Prasad, Abhijit, James, we may never know where exactly these data centers are physically running. So they are into undisclosed location and unmarked building where these services are hosted. Now, one data center may not be sufficient enough to handle a lot of data. So what we would do, we would combine these two on a high-speed redundant network, and that will be called a availability zone. So the first technical term you have to remember is called availability zone, or AZ for short, which is a group of data center. And once you start working with AWS, probably you would have access to availability zone for some services, and you would never see a data center behind the scene. You would always interact with a availability zone as the basic minimum block to get started. Right. So this is my availability zone, which is a group of data center. It may have one data center or more than one, but it is giving you the required resources, and they are all highly connected on a redundant network. Right. Now, these availability zones are further grouped together. So let's say we have a region, let's say called London. And in London, there is a availability zone A, availability zone B, availability zone C, which in turn is made up of multiple data center inside. And these three availability zones are combined together, and that is called a region. So region is the entity in which you would start hosting your application. If you go to AWS console and if you access some of the resources, it will all show up into a region. So region is the component in which you start building your application, and a region would be made up of multiple availability zone behind the scene. And you could go here, like if I go to this picture again, if I take here my mouse, Spain launched in 2022, availability zones are 3. If I go here, Osaka 21, and availability zones are 3. And similarly, you could get information about every location, like Northern Virginia, it has 6 availability zones inside it. So that's how we have hosted resources, hosted the infrastructure on which you could go ahead and build your own application if the need be. I hope everyone is following along. If there are any questions, let us know and we would be happy to answer. Apart from building this data center, what AWS did? AWS has hosted and connected all these. What are the locals and other zones? I'll talk about that, Prashant. Good question. I'll explain that in a minute. So, global infrastructure network, as we see here, this is the network which is a backbone of connectivity. So what we are seeing here, all these locations, we don't want to just rely on public internet. So what would happen? We have connected all of these on a redundant network, ensuring that when you are accessing the services, you get the best priority and you get the best performance for your application data. So all these are put together onto a global fully redundant 100 GB network, and AWS maintains this network. This ensures that we are able to give you the best performance and we have all the connectivity sorted on that. So we would be talking more on that as we move forward. So that is what a region is made up of. Now, when you want to access this region, let's see talk about what this region selection criteria is, and then I'll come back to this edge location also. So if you have to get started and say, okay, in AWS console, I would build an application, I have to start by selecting which region I would get into. So what should be your criteria? Let's say you are looking to buy a house. You would think that what is my criteria? Do I need to be near to my office? Do I need to be near a city center? Or do I need to be away from city center? I should have some criteria before I go ahead and say I want to buy this house. So same way, if you are creating a application, you have to decide that what should be the region where you would start building your location or application. And when I say region, this is a management console, which is an interface by which you would access AWS services graphically. And here are the list of regions. See this thing? So these regions are available and I can start building in most of them. Shouldn't be a problem depending on some factors. So my question to you is, what factors you would consider when you want to build your application? What do you mean by redundant physical cable connectivity? Yes, that is true. So redundancy is in form of physical connectivity, which is multiple cables connecting those locations. It is not one single cable. Yes. Okay, good. Price, compliance requirement, target customer location. Exactly. I agree on that. Pricing information. Yes, I agree on that. Many regulatory customer proximity location, nearest to your location, data storage. Exactly. So you may have to follow some compliance requirement. Maybe you are storing data of, let's say, customers in Europe. So there is a GDPR requirement which may say that this data can be processed only within European region, not beyond it. So you have to go ahead and follow that compliance. Like let's say if you have heard about MasterCard in India, right? MasterCard had some issues with operating in India because their servers were hosted outside, and Indian government has asked them to either bring those data back to India or stop doing functioning or stop being business here. So those type of legal requirement will always come into picture, and that's why AWS has posted or created these locations all over the world so that you could follow the regulatory requirement on that. So that is a compliance thing. Second, so compliance, if you want to check, these links will be available. Here are the different programs we follow as a company, and that would be giving you a peace of mind that, okay, somebody has audited us and has given us a rating that, yes, we follow the standards set by different governing bodies. Like in America, standards would be different. Some standards are global, like if I'm talking about PCI compliances, SOX compliance, these are global standard, but in every region, there may be some specific requirement, like Germany has C5 as a requirement. Asia Pacific, there is a security standard in Australia. Then there may be something on Japan and Singapore. So every country may have their own specific compliance, and AWS goes through different auditing process and gets the infrastructure and application verified for those requirements. So those compliance thing will be first factor. Second thing you would be referring is proximity. You need to ensure that you keep your data near to your user as much as possible so they get the best performance. And you could check that through a service called third party tool called Cloud Ping. And if you do the ping here, it would tell you that what is your latency to different AWS endpoint. So I'm based in London, and that's why I am having less latency for London region, and then probably better would be to host in Ireland or into Paris. So that is another aspect of hosting your application, that is your proximity. Third factor is cost, right? We do not have the same flat cost everywhere. So what would happen, depending on the cost of infrastructure which we have, like the manpower cost, the taxation, the real estate cost, we would have services with different cost settings. And I'm using a tool here which is called simple monthly calculator. I am going to a service called Amazon S3, in which I keep some data, and let's see, in Northern Virginia, what would be my price? So for 10,000 GB in Northern Virginia, my cost is going to be coming out to $29.88. Let me add more location and see how the cost may be different. Let's say Asia Pacific, Mumbai, 10,000 GB data. I have hosted that data there. Then I select something, let's say into Europe, let's say London, and I hosted 10,000 GB data there. And then I say, okay, I would be looking for Cape Town to host my 10,000 GB data. So same look data 10,000 GB, but if you see, pricing is different. In Northern Virginia $230, Africa 274, then Mumbai 250, London $240. So this can be different. So maybe you could decide that, okay, I want to keep my data near to my customer, so I would keep my prod systems, production systems near to users where they would access it, but I would keep my dev and QA environment into the location where it is cheaper to keep these services running. Probably still you have to consider the compliance, because if not, then you may still have to host everything into one location. But if there is a flexibility, you may want to look for ways to keep your cost low by hosting maybe your dev QA, or maybe your backup environment, or maybe your disaster recovery environment into the location which are cheaper, right? So that is another factor you may consider. Now, if you have observed this particular screen, you may have seen that cost in Northern Virginia is much cheaper, right? My question to you is, why cost in Northern Virginia is cheaper? Why we have less price to pay for the same amount of data into Northern Virginia? What is the lucrative thing about Northern Virginia? Why the cost is low? Anyone, any suggestions, any thoughts here that why the cost is low in Northern Virginia? And with guinea pig for AWS, it is. It is. Texas may be more easy, high usage, lots of data center and easy. And yes, you are right. Yes, cheaper hardware, probably yes. But I would say if you go back to the table which I was showing here in global infrastructure, you would find that Northern Virginia, which is here, is the place where we have 6 availability zone. So there are a huge number of resources available, purely supply and demand based principle. So if you have a lot of data, a lot of resources available, we can keep the cost low, and that is what your availability zone 6 is helping us. So because of that much of resource availability, we are able to keep the cost low. But that was not my actual question. My actual question was, like, now I'm rephrasing it, why AWS hosted these 6 availabilities in Northern Virginia, not into here into GovCloud, now not into Northern California, not into Sao Paulo, and not into UAE, or maybe into Sydney? What was that? What is wavelength zone? We will talk about that, Babita. Give me some time, I'll come back to that. Government locations, uh, Jayant, may be similar. Government cold. I'll give you a technical reason behind it. Now, let me see if I can get that thing displayed to you. It is a default region, but yes, I agree, Ivan, but why it is default region? Technical thing. See this. What you are seeing here is inter your submarine cable which carry your internet traffic. So if you look at this map, these cables are all basically coming from Northern Virginia and connecting Europe. So if you host your applications here, you would have better connectivity for your US based customers, no problem at all. And then European customer would also get better connectivity because these are like direct links coming up. You are not hopping from one link to another link. So that is the cable which are connecting your intercontinent, which are coming continents with internet traffic. And that becomes like a very interesting point for Northern Virginia to host the application and deliver it to the as much user as you can with a lower cost because there are ample resources. So that's why Northern Virginia is guinea pig for AWS. New services almost get started there, and then it can be hosted into different platform, and then we can keep on moving forward like that. So hopefully this thing is clear. Why Northern Virginia? Now, last thing here you may have to think about is service availability. Not every service may be available in all the places. We want to make services available in different places, but let me quickly give you an example here that how I could check it. So I am into AWS console. Let's say I go to a service here called VPC. And don't worry if you do not understand VPC, we'll talk about that. So if I go to VPC here, I can see all the regions here like it is Oregon, and then maybe other regions are also displayed here. Shouldn't be a problem at all, right? Give it few seconds here. So if you see, all my regions will be displayed here where I should be able to host a VPC as a service. See this, all the regions are available, right? These 10 which I have intentionally disabled, that's fine, but otherwise everything is available. But let's say if I go to services like Amazon Connect, let's see what happens. So if I'm going to the service Amazon Connect, let's see if I still see all the available information or not. So we are going to here the service which is called Amazon Connect, and let's see if it is operating in Oregon. Yes, it is. But if I look here, Ohio is not highlighted, California is not there, Mumbai, Osaka is not there, Ireland is not there, Paris, Stockholm is not there. So this service is not available in these locations, and that's why if I want to use it, I have to use any of the regions which is it is supported on. So these are the four factors you would consider when you want to select a region. Right. Hopefully this thing is clear. Let me talk about one more thing which is called edge location. Edge location are helping you to deliver your content faster. Let me give an example here. So this region here is Sydney. Let's say I hosted my application here. I have a user at this part of Australia and he or she wants to access my application. So now it looks very small thing here on the map, but it is a huge geographical region we are referencing here, which means request will go all over to Sydney, and then response will be coming from Sydney, and that may be giving a slow response to my user. What if we could have a caching location on near to my user? So my guess is probably this dot here representing Perth, and this dot here is representing Melbourne. So in this location, what we have done, we have hosted these edge location, or people just refer them as point of presence, which allows us to have some data cached and deliver it to user from there. So it would be much easier for them to get that data. So that is what we are calling as a edge location or point of presence. And if you take a political map and check these dots, you will find that these are mostly into the location where a lot of population lives. So if there are a lot of population living there, we are ensuring that we can deliver the content as fast as can. And then not every service is available. There are some services available there like Route 53, CloudFront, Lambda, WAF, and Shield, which will give you the best performance for type of the workload you are hosting. So that is what my edge location is. Now, hopefully this thing is clear. And what I will do, I will be giving you a single summary of all the topic we are discussing. See like this. So cloud computing, very basic, what it is, why we need it. Then we have where used it, who uses it, how much. So this information is available to you. I'll post it into the program page where you should be able to utilize. Are edge location data center? Yes, there is. So there are data centers there, but those data center are delivering some very specific service, not everything. An example I take to explain edge location is, let me go back to a blackboard and probably it will be easy for you. Blackboard, yes, this is my blackboard. So what may happen that you may have some superstore in your city. In a superstore, you will get everything: dog food, maybe you want a bike, maybe you want to buy some electronics or a mobile phone. Everything is available in a superstore. And then you may have a corner shop near to your house. That corner shop may not have all the product, but the basic product like maybe milk, bread, maybe eggs, those will be available into a corner shop. So you could go here and get things faster. But if you want to buy in bulk, probably what you would prefer, you will prefer to go to a superstore and buy things from there. This is, you could think it is your region, and this one is your edge location where we have smaller number of services available and they are intended to deliver content faster, whereas region where everything is available, all the services, and we deliver everything from a region. You could decide, hey, I would host my application which will be purely hosted into a region, or I would have some component hosted into edge. So it is a design question. You could answer it depending on your use case. Shouldn't be a problem at all, right? I hope this thing is clear. Everyone has got an idea. All right. uh, Let me go ahead and talk about more things here. I would talk about two more component here. One is called local zones and second is called wavelength zones. I know we are a little behind the time, but hopefully everyone is learning. That's why I'll keep on continuing. So local zone and wavelength zone. So we hosted regions, right? Let's say region is into Northern Virginia. Agree? Northern Virginia is the best place to run services. But if you look at lots of location, let's say Chicago, let's say you're New York. So in Chicago there are a lot of businesses. In New York there are a lot of businesses, right? What if we could give them services near to their location? So what we started building, we started building a subset of services available, and that subset of services is we call local zones. So local zone will basically give you compute power near to your actual physical location. So major cities where we have a lot of businesses running, that is where we started hosting local zones like Chicago, New York, then Hollywood, where a lot of processing is required. So those places is where we have hosted something called a local zone. So it is purely to cater to the need of industry in that location. Like New York, there are a lot of stock exchange information. Maybe another one we have in California, which is near to Hollywood, so there would be a lot of processing of Hollywood related stuff would be happening there. Chicago, a lot of industries operate near to Chicago, so they would get benefited. So that is a subset of services hosted in local zone and focus in to give compute power near to your user. That is your local zone, right? Hopefully this thing is clear. Let me now focus on wavelength zone and let me explain what this wavelength zone is, and then we will go ahead for a short break. Give me a minute. Let me write down wavelength zones. Sorry, I can't type and speak at the same time, but I'm trying. Wavelength zone. Now, let's say you have a mobile application. This mobile application is accessing 5G. Your backend is hosted in AWS. So what happens right now? You would be connecting to through your mobile to your mobile service provider or mobile operator. Let me write it down like this. And that mobile operator will then connect you to AWS. And then the request will come up like this, right? Which means your application would have to go through mobile operator network, then reach to AWS, and then deliver the result. What if we could host some infrastructure component in the mobile provider network itself or their location? So AWS hosted some services here. Now we have cut down on this path. So that is my wavelength zone. This works with collaboration with different providers, and through this we are able to get services delivered to user in a much faster fashion. So maybe Verizon, maybe Vodafone, maybe AT&T, these mobile provider work with AWS, and we host a partial infrastructure in their location to give you the better performance. That is called your wavelength zone. So if you are looking for building 5G application, maybe Using wavelength zone can help you in cut down on the latency and deliver faster result to your customer. That is a wavelength zone, right? So hopefully this thing is clear. Let me quickly, it is available on mobile operator. Yes, exactly. Let me quickly go here. I'll go to a service called EC2 to show you that what are options available. Now, these spatial infrastructure, which are called your local zone or wavelength zone, may not be available in all the places. So you have to be aware where it is available and where it is not. What is the difference between local zone and edge location? Edge location is more for caching. Local zone is more for compute. So databases you want to run, local zone. You want to run a web server, local zone. You want to keep a content cached for your user, it will be your cloud front, which will be running from edge location. So edge location is more on caching, whereas local zone is more on the processing side of the things. So see this. So I am into Oregon. In Oregon, there are local zones which are in Denver, which is in Las Vegas, and then these are another one which is Lex, and then there is a Portland, PDX, another is Seattle, and see these are wavelength zone which have been hosted with the help of Verizon here, and then obviously availability zones there. So depending on which region you are, you may see, like if I'm going to Mumbai, probably there would be no local zone there. I'm not sure. Let me explain it here. Let's see if there is something like this available in Mumbai. So in Mumbai, yes, we have a local zone. See this in Kolkata. Then another is in Delhi, and then three availability zone which are in Mumbai. So anywhere where we'll have a resources, we would utilize. Will it impact on the cost? See, if you are using a resource, you have to pay for it, right? So if you are looking for giving better performance and use edge location, yes, there would be a cost associated on it, and you have to pay money for that. But it depends. Again, it is your decision as an application owner or a business owner, what you want. Do you want better performance or cost, or maybe a mix between them? So you would decide based on that. Right. So this one single slide would help you to understand cloud computing. I have also created this one single slide for Amazon Web Services. So we will share these slides with you. So you would have one single page where all the basic information would be available for you to reference if the need be. All right. A wavelength zone is only for telecom. I would say anyone who wants to host a mobile application, they would benefit from edge location. All right. Good. Thank you. So